Okay, assignment 1. Very briefly, just in terms of content, before we even look at the assignment. Assignment 1 relies on everything, well, not everything, a bunch of stuff we learned today in the C++ basics lecture, and it relies on some of the STL stuff from next week. Like, basically these few things. In particular, STL containers. But here's the thing. I don't think a lot of next week's actually super complicated, and you're going to find this in general in the course. Writing C++ ain't that hard. Lots of good examples online. Understanding C++ kind of hard. So a lot of the lectures are about understanding the details of what's going on. You could start this assignment now, even without next week's lectures. I'm sure a lot of you could make good headway into it or finish it. But for the super conservative people, next Wednesday, by the end of next Wednesday, you've learned absolutely everything that you're ever going to learn that you need for the assignment. But you could pretty easily start today. The assignment, in a nutshell, is writing a C++ program that is able to take in 2 words, and it's able to find a word ladder between those 2 words. A word ladder is when I give you a word like cat, and then I give you a word like dog, and I ask you to find me a ladder from one word to another, only changing one letter at a time. However, you can't just do this. You can't just say, well, cat goes to dat, and then dat goes to dot, and then dot goes to dog. Right? We changed one letter at a time there, because every word that you change between has to be a valid English word. I don't think dat is a word. I could do a bigger example, like possum to tricks. Right? You can't just be like tossum, trussum, you know. You can't just do that. They have to be valid words. So you're going to write a program that can do that, right? And sometimes there are multiple solutions and stuff. The spec is like, the spec says some stuff. We'll talk about the spec next week too. Don't worry, it's not like the only time we'll talk about it. And sometimes I like talking about specs after people read it and start it, because right now it's all just abstract to you. But that's essentially what you're going to do. There is a function you're going to write called generate that takes in a starting word, an ending word, and basically a big dump of all the English words, right? So we're not asking you to figure out what's a valid English word. We're giving you a big list of all the English words that exist. There's a lot of stuff here, but basically how it works is that you breadth first search through the words. So if you start off with a word, for instance, like work, I'll just really quickly explain it. What you do, and you know that you have to get to like another word like, what's the play? Is it play here? Play. What your program does is, if you're going to have to refresh yourself on breadth first search if you've forgotten it, but it goes and says, well, OK, I know I have to go from work to play. So for instance, maybe I'll look at like, I'll change P to W to P, or like there's all the permutations, right? Because from work, you can get to a set of other words in the English language, right? You could figure out that set pretty easily. Maybe it's things like, what's the example? Word or dork, things like that. From work, you can get to this whole list of other things. And then from each of those words, you can get to more words. And eventually, in that search space, you'll eventually find play. And you're going to make a depth first don't do a depth first search. You're going to make a breadth first search to get there. And if you do that and you employ some basic things like references and stuff, you'll kind of get there. It's a pretty straightforward problem to solve if you don't think about performance, right? Because like for small words, it's quite quick. A computer could go through it quite quickly. So that's the crux of it. We give you some data types that we encourage that you use for it, but generally things like vectors and unordered sets and things will be useful. Blah, blah. But I'll just show you this really quickly. So what you do, just like the exercises and stuff, and I'm probably going to talk transparently for 10 minutes. So if you want to head off now, you can, but I'll talk for 10 minutes. We're not going to run massively over, just a few minutes over. When you clone the repo, you will then see a whole bunch of files, and we can see them here. All of this is pretty standard. Looks like your exercises, looks like everything else. Lib's just got catch2 in it. Don't need to worry. We have a source folder. It's got this file called english.txt. Has every English word in it that's valid. It's a very big file. You're going to open that with an input file stream and load it into some kind of structure. We then have a main file, and what that main file does is that it does nothing other than it calls a function readLexicon to load up all the words into some kind of object. It's not apparent from just this file what type that is. And then it passes that lexicon as well as the start and finish word into another file called generate. So there's a function called readLexicon that reads it into an object, and another one called generate. Then if we come here in wordladder.cpp, we will see those two functions. That's your assignment. You have to implement the function readLexicon, and what it does is it stores it in an unordered set of standard strings. That's a thing you can literally paste that into Google and you can get it. And then here you would implement that and it would return the unordered set of standard strings. And then you have a function called generate that takes in the from and the to, and it returns a vector of vectors of strings. Now that might be a little bit confusing, but if we go back to the spec for a second, what you'll remember is that sometimes there are multiple solutions that are equal, right? There are multiple solutions that are 5 steps away. So when we say vector of strings, that's a string, that's a vector of strings, that's a vector of strings. So many solutions, even though it's a vector of strings, will just be like one vector of strings in a vector with one item. You know what I mean? Because like this here's a vector of strings, but it's just like one element there. That's what you have to implement there. So the assignment's quite contained, which is nice. You write 2 functions. There's a .h file. You don't need to touch it. Where things get slightly more fun and interesting is that we would like you to write tests. Tests are good. We like tests. Tests are great because you can go and kind of write them yourself. You can probably, I'm sure you could Google a couple of examples if you want to. But yeah, we want you to write tests. It's not really more complicated than that. You can make many test cases, lots of examples. And we actually give you one test, and we do this to make your life really easy, which is this one. And this test is the hardest word ladder to generate. And we give this to you up front so you don't have this kind of unbounded problem not knowing how hard or slow your program might get. Atlases to Cabaret is the longest one to generate. So you can run this test on day 1 and see how long your code takes. In the spec, we tell you that on the CSE machine, we will give you 12 seconds for the longest test. So Atlases to Cabaret can take 12 seconds. Any longer than that, it's not like you lose marks. But how the auto marking works for this assignment is we basically will have tests just like you do, where we test little word, bigger word, bigger word, bigger word, bigger word, bigger word, bigger word, Atlases to Cabaret, like that. And every single one of those tests has a 12-second timeout. So if your test doesn't make 12 seconds, the test just gets canned and you get 0 for it. Very typical for students to like go through like 15 out of 16 tests, and the 16th one is the Cabaret one, and they just fail that one, and they get 15 out of 16 marks in the auto mark. Most students generally, once they start passing a few in the auto mark, they pass nearly everything or everything, just by the nature of the algorithm. You know what I mean? Your algorithm kind of works or it doesn't. And then the next question is it fast enough? But most of the marks just come from getting it working. Particularly if you're using references and stuff, things are going to work. So this whole section here is just talking about performance. This section here is just telling you that if you're scared of the test files and Catch 2, you can always just run a main file. I included a main file here for you just so you could run it if you want to. But you know, it's better to kind of, in theory, compile it with the tests as well. In terms of marking criteria, 50% of marks are auto-marked. Full stop, we run an auto marker, you get the marks. 25% come from a tutor looking at your tests and deciding if you wrote good tests. A good test is one that is right, naturally. They'll check if your test, if your code passes your tests, easy. They'll check if it looks like you tested all the kind of different things, 2-letter words, 3-letter words, single result, multi-result, no result, stuff like that. They'll check if like your tests are well abstracted. That one's pretty easy in this assignment. That's more a copy and paste for future assignments. And then is it clear? Did you write good notes? Again, pretty easy in this assignment to write good notes. So the testing part's fairly free marks broadly. But your tests need to be clear. They need to be logically broken up. They clearly need to build up. Like, you think about it. If someone was trying to understand your test, would they understand it? And then 25% of the marks comes from you adhering to this stuff on the course website. Your tutors will manually mark that as well. That's where the marks come from. However, and this is really important, and I'll just kind of jump to a couple things here. Don't cheat, don't plagiarize. We run plagiarism detecting on all your code. Really easy. Don't do that. Every term someone does it. We have a dry run for you just to make sure that your code actually compiles on the CSE machine so that you don't have some weird at-home issue that isn't noticed. So there's a dry run there to help you out, and it's due on the Friday of week 3. That's 2 weeks from now. The reason it's due on the Friday of week 3 is because I'm going to expect your tutors to have marked it by the Friday of week 4, which means you're going to have your first assignment back before census date, because I know that means a lot to some of you who need to decide if you think you're good enough for the course and all that kind of stuff. Don't worry, but that's our best attempt there. We don't accept late submissions. It's quite late for me to go into the philosophy of this, but my whole point is that we let your assignment be due as late as it can be. If you wanted late penalties, I would make your assignment due on the Monday of week 3. I would have released it 2 days ago, and then I would have said you can submit it 4 days late with a late penalty, right? So we literally make it due as late as we can. We have to mark it that night. Like, we get started marking that night, so please don't complain to me about no late penalties, because the solution will be that I'll ask you to submit your assignment earlier, if that makes sense, right? Obviously, there's like a reasonable margin. Like, if it's 10 minutes late, I don't care, but like, you know, it's due at 8 p.m. on that Friday. Now, here's the last point. This is kind of a big point I want to point out because it's quite new, hasn't been done before. Here's the problem with this course. This course is trivially solved in many ways by ChatGPT. You could probably go dump the assignment spec into ChatGPT and get a reasonably comprehensive answer. There's nothing I can do about that in the short time frame that I was given to prepare for this course. So here's what we're going to do instead, whether you like it or not, sadly. There are rules that you have to follow when it comes to preparing for this assignment. You need to make commits on at least 3 different days prior to the due date. You can't do all the work on 1 day or 2 days, right? So it's due on a Friday. That means the latest you can start it is the Wednesday of week 3. Work on it Wednesday, Thursday, Friday. We check your commits to make sure they're spread over 3 days. You don't have to push to GitLab every day. You can commit locally on your laptop and push up to GitLab later if you want to. All of your commits to master must successfully compile. I have set this repo up here so that every time you push to Git, we actually build your code. So do not push any code to GitLab. And generally, I would actually probably recommend not committing anything. It's probably a better explanation. Don't commit anything unless it compiles. Run make. If it gives you compile errors, don't commit it. That's important too. We want to make sure you always have compiled code. Number 3, your commit messages need to be meaningful. That's kind of obvious. And number 4, and this is the one that's going to pinch a few of you, your commits can be no longer than 50 lines of code. That means every time you do a commit to Git, it needs to be no more than 50 lines of code. So you have to commit in small chunks, and they always have to compile. Why am I doing this? It's frankly to stop a lot of you cheating, right? Because you can't go and take a big thing off ChatGPT. But it's even deeper than that for me, because a bunch of you here are going to ignore what I say and ignore the rules, and you're going to go read ChatGPT anyway. And you know what you're going to do with that? You're probably going to grab that, and you're probably going to try and break it up into little 50 lines of code and commit that. But it's not going to compile because you don't understand C++ because you're cheating. So you're going to have to understand C++, how to break it up and put it in little chunks of code to commit it. You know what? By that point, you probably learned the bloody thing, right? So I'm not saying do it because it's not good in your favor, but that's why they're there. And it's going to annoy a few of you, but just particularly to postgrads who are scared of Git because it's not taught. We're trying to get it taught in your program. Go do the Git setup activity, all of that. Like, just follow this, because there's going to be some of you that are going to send me your assignment as a zip on the due date and ask for mercy, and I don't know if we'll be able to provide it. Last 2 minutes, I don't think I have, last 1 minute maybe, I don't think I have anything else really left here to say. I could recap breadth first search, I could read through the spec, but you can all read. That's the gist of it. We have time next week, so go read the assignment, maybe make a little start on it, get it compiling, go write a basic test case, nothing stopping you doing that. And then next week, as we learn about STL, you can really warm up into it. So is that all good? Any kind of pressing questions?
Can I just output something like test, vector test, so it makes sure it's right?
Yeah, sure. Yeah, for sure. Feel free to. Someone says, any commit time interval requirement? No. Any other questions about Git? We can ask on the forum. You don't need branches for people who've come from undergrad. You don't need branches or anything. It's very straightforward. Cool. Have a great evening, everyone, and I'll see you next Monday.